My name's Rick Newman. I'm responsible for OpenPOWER strategy and market development for Europe. I've actually been, although I'm American, I've been in Europe for the last 6 years. 2 years in Germany, then 2 years in Prague, covering Central and Eastern Europe, and now I'm based in London and I cover all of Europe. So it's been an interesting experience, and I have background in many countries now. There's never been a more exciting time to be in HPC and IBM. We've gone from, it's all about how fast the processor is, to bringing cognitive, Watson yes, but all of cognitive to bear on HPC issues. And it's a sea change. You know, IDC, I saw a statistic the other day that says 80% of all HPC customers will use multiple processors. I use E4 as an example. If you walk by their booth, you've got ARM, you've got OpenPOWER, and you see Intel everywhere. It's multiple stories now, and you can bring the right compute power to the right problems in the right way. So what's interesting is, we in Power have spent the last several years going from an enterprise class down into a 1 and 2 socket server. And we brought all of the learnings from the past at the enterprise level and then brought it down to a scale-out architecture that we never had in the past. Well, to do that, one of the things we want to do is we want to solve tomorrow's issues, not just today's. So by combining with the members of OpenPOWER like Google and Rackspace and Micron and Mellanox, and then opening up the architecture, what we've done is several things. One, I would say every time a company tries to control innovation, they fail. And you can go through our history, and I'm sure you've seen it, that control point never works. If you open, like OpenStack software, now you get different perspectives, different IP, and you bring that all together around a common core, like OpenPOWER, and now you have true innovation. So it's a fun world. I actually talk to OpenPOWER partners who keep saying, so how much do I pay? I want the 1 and 2 socket architectural design, reference design. How much is that? You joined OpenPOWER. Yeah. No, this is open, it's free. And the products that come out, I've walked by booths, both here and in Austin, and I'll see an offering from a company that I didn't know was working on one to solve something that I didn't know they were willing to solve. At CeBIT, I actually had a company called Colab who stopped me and said, oh, you're with OpenPOWER. Yeah. This is fascinating. You need to talk about it more. Well, why do you say that? He said, well, I've moved my ISV software over to OpenPOWER, and now it's my standard. Let me tell you why. And so we spent about 10 minutes talking about why he's moved his cloud software to Power. And then I asked him, well, are you a member? He says, no, but I'm going to get around to it. Yeah. And now he's joined, etc. But that's what happens when you open up an architecture. So OpenPOWER is a foundation, not controlled by IBM. We're one of the voting members of the board, but I said there's several others like Google and Rackspace and Mellanox and Micron, etc. The goal is to do a few things. One is to bring that innovation to bear. It's also then to publish it back out to the community. So at our last OpenPOWER Summit, Rackspace and Google said, yes, we have something today in Power 8, but we're also going to work on an open compute compliant platform together for Power 9 and contribute the architecture back. And that's where it gets interesting. Rackspace did the same thing on their own with Power 8. There's an OCP compliant Power node, not from IBM, done by Rackspace to fit into their environment, and then they contribute it back to create more innovation and more openness. Yeah, they brought our chip, and then they used the architecture we published, so the CAPI base, the Power chipset, and then they did the form factor that meets the open compute compliant standards.
And would this then produce the actual hardware?
OMDs.
OMDs.
So if you go and call, actually I think we now have almost every single OMD is working with someone on an OpenPOWER compliant piece of hardware.
And what you do then is you have this design, this OpenPOWER design, you go there and you get the chips basically.
You buy the chips, everyone uses the ODM to do the production. And in some cases, what you'll see is someone raising their hand, and we had this workshop recently with someone who's a power partner and said, I want to do a design that looks like this. And I can't do the actual reference completely. And we said, well, you should know we're working with another OpenPOWER partner who has the same exact idea. Yep. If you'll wait 4 months, the hardware will now be available, and what you really want that hardware for is to put your solution on it. Yep. And it's at a price point and an architecture that we don't have in the market yet, but you don't need to do the development. He's doing it for you.
Yeah, it makes life easier.
Yeah, it makes life and a lot more fun. So from an IBM perspective, one of the struggles in innovation is, there's the old saying, build a better mousetrap and they will come. You have to be able to get the word out about the mousetrap. And the OpenPOWER Foundation, by having now over 210 members, we expect to exit June over 230. That news is spreading. Those innovations are occurring. And they're taking our architectural design and broadening it in ways IBM never could. It's a scale-out environment. It's a place where IBM never played in the past. So people would say, well, I'm going to do a big data project. I'll get the gray box I've got in the corner in the closet, because I've got a whole stack of them. They're inexpensive. And I'll start my project. IBM, what do you have in that same arena? And honestly, typically we would come back with a $35,000 price point. Now, performance and architecture makes that a valid price point, but it's typically not where people start. Now you can see $6,000 and $7,000 boxes in the market using the power chip, using CAPI, using all the innovation, and you can have those in the closet at that kind of a price point. Yeah. And then you scale them out. Yeah. And it's a place we didn't exist before. Yeah. It's part of what's interesting about the environment today. So, I've talked to someone who says, look, I'm going to start with 1,800 nodes to do an HPC environment. Someone else, using the same architecture, the same box, will say, oh, I'm going to buy 8 nodes to start testing and start porting code and optimizing for NVIDIA come fall for their NVLink on our Minsky box. Others will say, no, I'm buying 2. And that's how I'm starting. So you've got this huge scale, which is the design point, but talking about 1,800 nodes, not unusual. Talking about buying 2 boxes, also not unusual.
Yeah. Now, the nice thing is that it's an ecosystem where you can...
And you can enter at any point, and there's no stopping required. Yeah. And then back to the cognitive point, one of the things we keep talking about is it's not just that speed of how fast you can turn in circles anymore. So we've seen cognitive applied to some of the HPC workloads, where cognitive will come back and tell you, oh, let me identify the 80% of the data you don't need to analyze. Yeah. Let me talk to you about the 80% of the experiments you don't need to run, because based on the data you have, we can now point you in the right direction. Yeah. So having that cognitive bent on HPC workloads means you can lower your investment on hardware, you can operate more quickly, come to conclusions more quickly. We offer more from an OpenPOWER perspective. So for example, if you came to us today and said, and I'll move in an interesting direction that OpenPOWER has ended up moving in at times, I want to do my own processor. Yeah. I want to do my own processor, I'm going to put my own security on it, and it's going to be, I'll apply to the EU to be a secure server with EU standards. Yeah. We will help you do that. Yeah. We will create a project team within the OpenPOWER organization. We'll help you with the microarchitecture. We'll help you do the design, any firmware changes, and we'll bring many years of experience of designing systems to the system side as well. And we're doing that work with several governments. Yeah. And because it's, and also with ARM, it's a different kind of openness. You have to pay, it's open, but you have to pay a license, of course. Yeah, and you join OpenPOWER, and like I said, people keep asking for the price tag, and you joined OpenPOWER. There's your price tag. It could be OpenPOWER. there's some white papers floating around about the open scientific cloud, about how they're going to interconnect all of the supercomputer sites and share more information. And what's interesting is not only could it be open power, but we have investments in Europe with the Zurich lab, with Berblingen, with Mach, all working with different parts of the EU to do exactly that, helping companies create IP. Some companies, I mentioned E4 before, they're doing things with energy that with open power and things we'll never work on, at least in the near future, because that's their focus. They have IP around energy management that then applies to open power. That's perfect for what the EU wants to do. Open power is interesting. If you go to the foundation site, some of the things you can see is there's an area where acceleration. We haven't talked much about acceleration. I mentioned capping. But one of our architectural principles is all built around acceleration. It's about moving processing to where the data is, whether that's a GPU or an FPGA or simply something that needs high-speed I/O and high-speed memory bandwidth. So if you go to one of the parts of the foundation page, you can look at CAPI acceleration that people have done. To the point of, I was shown yesterday, someone has a design with a OpenPOWER box on the top of a rack and all disk to address a price point where they're using half the energy and half the price as doing that with a typical storage node. You can look at image data processing and acceleration from some companies who are using OpenPOWER with an FPGA to train their neural network to do image recognition. And that's everything from driving a car to border control. So that by the time you walk up to present your passport, they've already decided if they have more than one of your face in their database. Perfect place to be. We're populating almost a library within the foundation. We're not where it will be in a year from now. There's still a little bit of searching that you have to do. And one of the challenges is getting everything contributed back in a way that we can easily link to it. I mentioned, Colab. They hadn't joined OpenPOWER. They've migrated their software. They have a cloud offering. They have an on-prem offering. We had no idea, and they do calendaring and messaging, etc. Out of Zurich, actually. And you have that line you're walking with, trying to control so that you can get information, so you can publish it so everyone knows. And then it's open. Anyone can do anything. Now, the other piece of it, though, is work groups. I don't know if you're familiar with our work groups within OpenPOWER. There's 13 of them. And it's everything from, there's a work group on acceleration to personalized medicine. And it's groups within OpenPOWER, sometimes with IBM, sometimes without, many without, where they said, you have technology, and I have technology that will apply to the same problem. And usually it's 3 to 7 members who then form a work group who work on an issue together. Some of the outcomes that are starting to occur, like accelerated genomic processing, where in under 20 minutes they can sequence your genome. So in theory, you could go to your GP the first time, they take blood while you're waiting, they do the sequencing, and they can say, well, you're predisposed for diabetes. You're 21 years old. But let's start talking now about what we can do so that in 40 years, you don't have this issue. It's a fascinating realm. So key tools, work on OpenPOWER, cloud management software from many companies. You manage it in a heterogeneous way, just like you would anywhere else. We provide many of the tools that we use as part of OpenPOWER. Now, there's other folks who will say, no, we want to do some real work within the processor, where they'll contract with us to ask for our help, because there's not many people in the game anymore that can apply the experience level we can to solving some of those issues. And then our goal is always, in those discussions, here's the tools, let's teach you how to use them, let's do skills transfer, and then we'll move out. We want to create independence. That's critical. We can't be everywhere. But once you do that skills transfer and that knowledge transfer, countries are using it to change their economic condition. And we're unique in offering that skills transfer and those tools and that ability. We always joke that we've stopped counting new members, and we still do count them. As soon as you put the chart up, it's changed. There's more.
Yeah.
I actually would say, but in 5 years, we won't count anymore.
Yeah.
The number becomes irrelevant because it continues to grow and grow and grow. We published for the first time a processor roadmap when we talked about the Coral Wind and some other things. And we've got P10 sitting out here. There'll be new processors. But what'll be truly interesting is we'll be talking more and more about cognitive. Almost cognitive. And applying things like Watson. It will almost become, my view, the processor's no longer interesting. It's sitting behind. It's sitting somewhere, you need it. There's certain workloads where you'll say, no, I need that multi-thread. I need what it will do for me.
Yeah.
But it's all the entire architecture and then the application on top of the cognitive, that's what we'll find critical.
Yeah, but in the end, you need a processor.
You do need it, and we will still be there.
And there's still a few people, the ones that are here, which are interested in architectures and how do you say that? Architectures and processors. So
yeah, as we are, right? We'll continue.
Yeah.
And if I said we published the roadmap. We're still doing this.
Yeah.
It will be an important part, but not nearly as important part as it is today. It's about the architecture. It's about the acceleration. There's processor there. There's FPGA there. There's NVIDIA with the GPUs there. It's a broad architecture.
Yeah.
It's about creating the open environment that software has enjoyed with OpenStack for the last several years.
Yeah.
Now, I remember when OpenStack came in, people, we're not using that. We're not touching those tools. There's no control. And now the joke is always, if you ask a customer, are you using an open database? It depends on who you ask at the customer, because they're using it. Not everyone's aware it's being used, but they're using it. Yeah. And the performance that you can see is fantastic. It's now becoming accepted to be in the OpenStack environment. And many companies are setting a strategy around OpenStack. Same thing will happen on the hardware side. It's this, Google made the comment, it's about software portability. It's about moving the software workload to the right CPU to get the right result.
Yeah.
And I was asked many questions about, well, what are they talking about? What are they doing? They said they've already done most of the work, 80% of the work for power. As more and more bellwether companies, lighthouse companies move to that same mindset, then it's really about what can I bring you for your workload? And OpenPOWER brings more and more because more and more people contribute. One of the interesting use cases, and I talk a lot about use cases because it's truly where you can apply all the aspects of OpenPOWER. And it's things that we're doing with partners and partners are doing without us. And one of the ones, I was talking to a retailer recently who said, what I want to marry is social data, weather data, and unique offerings to an individual. I said, okay, what are you talking about? And when I was in Germany, I asked, when I first moved there, where do you go on vacation? I haven't lived in Europe before. I spent my time in the US, and I was told Mallorca. I've never heard of Mallorca. Let me look. So this is fantastic. So I went and took my family, 2 small children and wife, to go to Mallorca. Where it gets interesting, if I started tweeting while I'm on the way to the airport, can't wait, to go on vacation with my family, as many other people are sending out their tweets about their vacations to Mallorca. And you arrive at the airport, and what you don't know is the weather pattern has just changed, and it's going to rain. Well, if you had that ability to say, well, wait a minute, I've got real-time weather information at a high level of confidence. I know where these people are going, and I know it's a family with small children. If it rains for 3 days, if I can give them a best offer of, let me give you a coupon for an umbrella, which is going to be right next to the board game so your children have something to do, right next to the cards to play on the airplane, And I can give you that information as you're walking to your gate, so that you can say, ooh. Oh, and it also says there's a store up ahead on the left. Once my family gets past that store, I'm not turning two small children back behind and moving back where we came when they're excited to go on vacation. It's a small thing, but it changes the way you interact in a retail environment. And you said, process is important. Well, having all those threads coming in at the same time, all those pieces of information, doing the predictability on the weather side, knowing a buying pattern, knowing where my family is going, and doing something about it in a time where I can make a purchase, that's that marrying of the big data, the cognitive, the processor capability, and the OpenPOWER environment.
They should have swapped you with someone who doesn't care about rain and wants to have a cheap flight to Mallorca.
Yeah.
And then send you off to...
send me somewhere else.
Somewhere else. They should do that. They can do that in 5 years.
Yeah, exactly. What I would tell you is, you will see cognitive become the underpinning of everything we do. It's not an offering. Yeah, we have products that will help you do cognitive analysis. It's how we do business. And increasingly, it's how our customers will do business. If you're not cognitive, it will be like years ago when they would say, oh, you're in, I don't even remember this phrase, you have islands of automation and your organization doesn't talk to each other and you're at a competitive disadvantage. It'll be, oh, you're not operating on cognitive principles? You don't have a competitive advantage anymore. So what you'll see is IBM running cognitive through everything we do and then offering it out to our customers to make them cognitive businesses.
Okay, thanks a lot.
Thank you.